Okay, so in this example, we're going to use this formula, Q is equal to mc delta theta, to figure out how much energy it's going to take to increase the temperature of something. So in our question, we're going to have a lump of copper that has a mass of 500 grams, and that's going to increase in temperature by 20 degrees Celsius. Okay, so what do we need for this? We're going to work out Q. Q is the amount of energy that we're looking for here. So M, we have mass, that's fine, except we want the mass of the copper, which is 500 grams in kilograms. 0.5 kilograms. We also want C, which is specific heat capacity. So C, specific heat capacity of copper, which is 390 joules per kilogram per degree or per Kelvin. Right, 390. And we need delta theta, which is the change in temperature. Now remember, delta theta is one variable. It's not delta multiplied by theta. It's not two variables multiplied. It's delta for change and theta for temperature. So this is change in temperature. And the change in temperature in this case was an increase of 20 degrees Celsius. So that's 20 degrees. Okay, now to approach the problem, we will need the formula. Q is equal to mc delta theta. And we're doing the mass of the copper, the specific heat capacity of copper. So we use these little subscripts to identify what we're doing. Not so much of an issue for these sort of simple problems where you just one shot at the equation, but for later calculations, you have to keep a track of different variables, so these subscripts are important. And delta theta, in this case, only one change in temperature, so just delta theta is fine. So substitute in all our values. Q is what we're trying to find. M is 0.5 kilograms. C, keeping everything in SI units, 390. And delta theta is 20. So that's 0.5 by 20 is 10. 10 by 390, 3,900 joules, or just J. And that is Q, the amount of energy. That's relatively easy. We'll look at another example in the next video where instead of working out the amount of energy that's needed, we're given the amount of energy and we're trying to figure out, well, what's the change in temperature, or even better, what's the final temperature reached from something. So at a starting temperature of 10 degrees or whatever, what's the final temperature that it reaches if you give it this amount of energy? Okay.